This is Alexia and Madeline's model for design and technologies. So the storybook we decided to use for our model was Cinderella. We chose the story of Cinderella because it is one that all children are familiar with. Therefore, they would be able to understand the movements within our model and why they are occurring. Throughout the design stage, we analysed which scenes from the story would work well with a pneumatic system and electrical circuit.
We always knew we wanted to incorporate the iconic scene where Cinderella leaves her shoe on the palace's staircase, and we thought the best way to highlight this was to have a spotlight shining on the shoe. In order to be able to show this, however, we had to show how she lost her shoe in the first place. This is when the idea of having her run away towards the carriage came to us, and it was perfect because we had the tools to make it happen.
As you can see, our model fits within the size guides of 40 times 40 times 40. And because of that reasoning and the fact that everything's stuck down by either glue or sticky tape, nothing will fall out and it can be handled very easily.
So we will now move on to the demonstration of our model. As you can see, the pneumatic system pulls Cinderella away from the staircase and towards the carriage. Here, she then collides with a split pin which acts as a conductor of a closed circuit, enabling the light bulb to turn on and shine on the shoe which was left behind. You may also notice that in the background there is a clock with its hands pointing to midnight, which in the story is known to be the time when the spell wears off and Cinderella must return home. Now we will show you the back of our model. As you can see, all the wiring and the plastic tubing is concealed from the audience, but it's still easily accessible for operational needs.
The systems we integrated within our model were pneumatics and electrical circuits. Based on the assessment criteria, we designed our model to have the two mechanisms be a part of one dependent system. We achieved this by creating a closed electrical circuit within our pneumatic system, so that when Cinderella reached a certain point, she connected the circuit, which resulted in the electrical system to light up the bulb. Within the pneumatic system, we connected the plastic tubing to one side of each syringe, which were filled with air. This allowed for Cinderella to move forward towards the carriage through the concept of the pulley system. This stage of the folio is linked to the Australian curriculum due to its connection in the overarching aim of the design and technologies learning area, using systems to generate design ideas. Specific year-level band descriptors state how students are expected to individually and collaboratively identify and sequence steps needed for a design task.
We both believe that using everyday materials would be the best way to construct our model. Aside from the equipment we were given in class, the materials were all simple objects you could easily find around your house. These include a cardboard box, split pins, batteries, white paint, coloured paper, which was used to make the steps that Cinderella's shoe is left on, laminating sheets to protect the characters within the story of getting ruined, straws to help keep the steps up, and tape to keep everything secure. The materials we were given in class consisted of syringes, electrical wires, battery pack, and plastic tubing. To construct the overall model, we also needed some tools, which included a hot glue gun, a Stanley knife, scissors, a printer, and a laminator. By using such simple tools and materials, we were able to demonstrate how this activity can easily be adapted to a classroom setting. Students can easily complete this task in small groups or even at home in their spare time.
Although our final model was successful, we did encounter a few challenges and problems along the way. An example of this was in the construction of our two systems. Due to misunderstanding the task at hand, we believed that the systems had to work independently. We therefore created an electrical circuit which works separately from the pneumatic system. And this proved to be incredibly difficult to connect a large closed circuit between the light and metal conductors attached to Cinderella. However, as a team, we revisited the circuits and used the knowledge we obtained from our workshops to create a closed electrical circuit which worked effectively and was easily accessible in case any changes had to be made. Evaluation is a key aspect of the design process, as it provides the opportunity to critique the decisions made and analyse the effectiveness of the design. ACARA's technology structure supports this by emphasising how students need to make judgments on their process and consider the implications and consequences of these designs.